Hello everyone, this is Karthikeyan. I am a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and Global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem Walk on the Axis, which was asked in October Cook-Off 2014. The difficulty level of the problem is Cakewalk and the prerequisites are none. And the number of accepted solutions of the problem in the contest were 2062. Now let's move on to the problem statement. So in this problem, we are given n plus 1 lights, or basically we are given n plus 1 coordinates on the x-axis. So now I would refer lights as coordinates. Coordinates are placed at 0, 0, 1, 0 till n, 0. So we are having n plus 1 coordinates on the x-axis, which are having their value of their y coordinate equal to 0 since they are on the x-axis, and the value of their x coordinate ranges from 0 till n, 0, 1, 2, 3 till n. Now initially all the coordinates are considered as active, or basically all the lights are considered as on. You want to turn off all of them using a particular pattern. Okay, now first of all we will start at the origin, which is 0, 0. Then we walk to the rightmost light that is turned on and turn it off. So we start at the origin and walk to the rightmost light. Which is the rightmost light? It is n, 0. Okay, and after turning the rightmost light, we walk to the leftmost light. Which is the leftmost light? It is 0, 0, which is the origin, and then we turn it off. Okay, then again to the rightmost light, that is on, and then again to the leftmost light, that is on. Okay, we will stop after turning off all the lights. We want to know that how much distance we walked in the process, and the distance from 2 points on the x coordinate, which is a, 0 and b, 0, is the absolute value of a minus b. For example, if we moved from 3, 0 to 5, 0, then we moved from 3 to 4, then from 4 to 5. So we moved a distance of 2. Okay, if we moved from 8, 0 to 5, 0, then we moved from 8 to 7, 7 to 6 and 6 to 5. So we moved a distance of 3, which is 8 minus 5. So now let's move on to a few of the test cases. Okay, let us suppose that we are having 5 lights. Okay, or the value of n is equal to 5. So we would be having 6 points on the x-axis. Where those points would be? The first point would be at 0. The second point would be at 1, 2, 3, 4 and 5. Okay, now I would write a sequence in which I would visit these points. Okay, initially I am at the point number 0. I would go at the rightmost point. I would go at 5. I would turn it off. After this, I would go at the leftmost point, which is 0. I would turn it off. After this, I would go at the rightmost point again, which is 4. I would turn it off. After this, I would go to the leftmost point, which is 1. I would turn it off. After this, I would go to the rightmost point, which is 3. I would turn it off. After this, I would go to the leftmost point, which is 2. Okay, and I would turn it off. Now, so by this sequence, we can calculate the distance that we moved. Okay, so let us calculate the distance. We moved from 0 to 5. So the distance would be absolute of 5 minus 0. And since 5 is greater than 0, so it would be 5 minus 0. Now, we moved from 5 to 0. So it would be again 5 minus 0. Then we moved from 0 to 4. So it would be 4 minus 0. After this, we moved from 4 to 1. So it would be 4 minus 1. After this, we moved from 1 to 3. So it would be 3 minus 1. And after this, we moved from 3 to 2. So it would be 3 minus 2. Now, let's write the same expression for n equal to 7. Okay. Now, when n is equal to 7, we are having something like this. 0, 1, 2, 3, 4, 5, 6 and 7. We are standing at the point 0. Now, we want to turn off the rightmost light, which is 7. We turn it off. Now, we want to turn off the leftmost light, which is 0. We turn it off. We want to turn off the rightmost light again, which is 6. We turn it off. We want to turn off the leftmost light again, which is 1. We turn it off. Now, again the rightmost light, which is 5. Again the leftmost light, which is 2. Again the rightmost light, which is 4. and then again the leftmost light, which is 3. Okay, so let's find the distance that we moved in this process. So it would be equal to 7 minus 0 plus we move from 0 to 7, then again 7 minus 0 because we moved from 7 to 0, then 6 minus 0 because we moved from 0 to 6, then 6 minus 1 because we moved from 6 to 1, then 5 minus 1 because we moved from 1 to 5, then it is 5 minus 2 because we moved from 5 to 2, then it is 4 minus 2 because we moved from 2 to 4, and then it is 4 minus 3 because we moved from 4 to 3. Okay, so this is the expression we would have for n equal to 7. Now let's generalize the formula. Now let's write an expression for n equal to 5 here. Okay, see, we are having every number that is greater than 2, which is 5, 4 and 3. We are having 5 minus 0, 5 minus 0, 2 times. 4, we are having 4 2 times as well. Here is a 4, here is a 4. We are having 3 2 times as well. Here is a 3 and here is a 3. So every number which is greater than 5 by 2, which is equal to 2, we are having it 2 times. Okay, so which is 5 plus 4 plus 3. And every number which is less than this 2, we are having it 2 times in the opposite direction, which is only 1. Okay, we are having 1 as minus, we are having 1 as minus, so we will write minus 2 of 1, and we are having this 2 itself as negative, which is here. So now let's write the same expression for this particular pattern. Okay, see, now what is the value of n by 2? The value of n by 2 would be 3. Now every number which is greater than 3 is 4, 5, 6 and 7. So we must be having 4, 5, 6 and 7, each of them 2 times in the positive fashion. So it is 2 times 4 plus 5 plus 6 plus 7, and every number which is less than 3, we must be having that 2 times in the negative fashion, which is 1 plus 2, and 3 itself in the negative fashion for only once. Now let us see whether we have this or not, whether the formula is correct or not. So we are having 4 2 times. You can see that we are having 4 here, we are having 4 here. Now let us see we are having 5 2 times or not. We are having 5 here, we are having 5 here. Now let us see we are having 6 2 times or not. We are having 6 here, we are having 6 here. Now let us see we are having 7 2 times or not. We are having 7 here and we are having 7 here. So every number which is greater than 3, we are having it 2 times. Okay, 2 times of that number in our answer. Now every number which is less than 3 and is a positive number, we are having 2 times of it in the answer in a negative way. Okay, now let us see whether we are having it or not. We are having 1 here in a negative way, 1 here in a negative way. Now we are having 2 here in a negative way, 2 here in a negative way. So okay, the numbers which are less than 3 are also present in a negative way. Now let us see whether we are having 3 only for once in a negative way. Yes, we are having 3 only for once in a negative way. So okay, this expression is satisfied. So we can say whenever n is odd, okay, whenever n is not a multiple of 2 or n modulo 2 is not equal to 0, then we can say that the answer would be something like this. For all the numbers which are greater than n by 2, we take 2 times of those numbers. Okay, for all the numbers greater than n by 2, we take 2 times of those numbers as positive. And for all the numbers which are less than n by 2, we take 2 times of those numbers as negative. And we take n by 2 itself as negative. Okay. So we can see that this formula is correct from these two derivations which I showed you here for n equal to 5 and n equal to 7. Now let's derive the formula for n being even. Okay. So let's write this expression for n equal to 6. When we are having n equal to 6, then we are having points as like this. Okay, we are first standing at 0. We would move to the rightmost light, which is 6. We turned it off. We would move to 0 back again because it is the leftmost light. Then which is the rightmost light from here? 5. Go here. Now the leftmost light, it is 1. Come here. Rightmost light, 4. Come here. Leftmost light, 2. Come here. Rightmost light 3, come here. Okay, so now let's write an expression for this. It would be, we move from 0 to 6, so it would be 6 minus 0. Then we move from 6 to 0, so it would be again 6 minus 0. Then we move from 0 to 5, then it would be 5 minus 0. We move from 5 to 1, it would be 5 minus 1. We move from 1 to 4, it would be 4 minus 1. Then we move from 4 to 2, it would be 4 minus 2. Then we moved from 2 to 3, it would be 3 minus 2. So here, what is the value of n by 2? For n equal to 6, the value of n by 2 is 3. So now let's trace the same pattern. Okay. Every number which is greater than 3, what are those numbers? 4, 5 and 6. So 4 is occurring here as a positive number. 5 is occurring here as 4 is occurring here as a positive number 2 times. 5 is occurring here as a positive number and here as a positive number. And 6 is occurring here as a positive number and here as a positive number. So every number which is greater than 3 is occurring as a positive number 2 times. Now, every number which is less than 3, now let's check for them. Here, 1 is less than 3, it is occurring once here and once here. Now, 2 is less than 3, it is occurring once here and once here. So every number which is less than 3 is occurring 2 times as a negative number. So it would be 2 into 1 plus 2. And 3 itself is occurring only for once as a positive number, which is only here, plus 3. Now, this is different from the case of that of n being odd. When n was odd, then n by 2 was occurring as a negative number. And when n is even, then n by 2 is occurring as a positive number. So, we can again derive this expression for another value of n which is even. Let's derive it for n equal to 8. Okay. So, it is 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now, initially we are standing at 0. We go on to 8, turn it off. Then we come on back to 0, turn it off. We go on back to 7, turn it off. We come on back to 1, turn it off. We go on back to 6, turn it off. We come on back to 2, turn it off. Now, what is the rightmost light? It is 5. What is the leftmost light? It is 3. What is the rightmost light? There is only one light remaining, so it would be 4. Now let's write an expression for this. We go from 0 to 8, so it would be 8 minus 0. We go from 8 to 0, it would be again 8 minus 0. Then we go from 0 to 7, it would be 7 minus 0. Then we go from 7 to 1, it would be 7 minus 1. Then we go from 1 to 6, it would be 6 minus 1. Then we go from 6 to 2, it would be 6 minus 2. Then we go from 2 to 5, it would be 5 minus 2. Then we go from 5 to 3, it would be 5 minus 3. Then we go from 3 to 4, it would be 4 minus 3. Okay. So it would be 4 minus 3. Now, what is the value of n by 2? It is equal to 4. Now, every number which is greater than n by 2, let's see how many number of times it is occurring. Okay. According to a formula, it should occur 2 numbers of times. Okay. 8 is greater than 4, it is occurring 2 number of times. 7, it is occurring 2 numbers of times. 6, it is also occurring 2 times. 5, it is also occurring 2 times. So we can write that 2 times 5 plus 6 plus 7 plus 8. Okay. Now let's check for numbers which are less than n by 2. Now, 1, it is occurring once here and once here as a negative number. 2, it is also occurring 2 times as a negative number. 3, it is also occurring 2 times as a negative number. So it would be 1 plus 2 plus 3. Now, 4 itself is occurring only once as a positive number. So it would be plus 4. So we can say that when n is even, when n modulo 2 is equal 0, then all the numbers which are greater than n by 2, they occur 2 times as a positive number, and all the numbers which are less than n by 2, they occur 2 times as a negative number, and the number n by 2 itself occurs as a positive number only once. So this is the expression for n being even. Now let's revise the expression for n being odd. Now when n is odd, then all the numbers that are greater than n by 2, that occurs 2 times as a positive number, all the numbers that are less than n by 2, they occur 2 times as a negative number, and the number n by 2 itself occurs only for once as a negative number. So these are the two expressions for n being even and n being odd, and we would handle the case for n equal to 1 separately, for which the answer would be 2, because we are having only 2 lights. We move from 0 to 1, this is a distance of 1. We again move back from 1 to 0, so this is a distance of 1. So the answer would be 2 for n equal to 2, and all the other cases can be solved by using this generalization. Now, how can we solve this generalization in a quicker manner? Now let's discuss on that. So what we want, we know the number n by 2. So we want the sum of all the numbers from n by 2 plus 1 till n, and the sum of all the numbers from 0 till n by 2 minus 1. So basically the sum of all the numbers from 0 to n by 2 minus 1 plus the sum of all the numbers from n by 2 plus 1 till n, and the number n by 2 itself being plus minus n by 2. It is plus when n is even and minus when n is odd. Okay, so we just want the sum of all the numbers from 0 to n by 2 minus 1 and n by 2 plus 1 to n. So here we can use a prefix array. So what is a prefix array? Let us discuss on that. Suppose that we are having something like this. Okay. Now prefix of 0 is 0. Prefix of 1 would be equal to prefix, the previous value of the prefix plus the current element. It would be 1. Now it would be equal to the previous value, which is 1, plus the current element, which is 2. It would be equal to 3. Now this would be equal to the previous value plus the current element. So this would be equal to 6. This would be equal to the previous value plus the current element. So 10. Now 10 plus 5 would be equal to 15. Now 15 plus 6 would be equal to 21. Now 21 plus 7 would be equal to 28. So what does prefix of I indicates? Prefix of I indicates the sum of first I numbers. Okay. Now if we want the sum of the numbers from L to R, then what can we write? What does prefix of L indicate? Prefix of L has all the numbers from 1 to L. What does prefix of R has? Prefix of R has all the numbers from 1 to R. So if we are having L here, R here, and 1 here, and suppose that L minus 1 here, what is prefix of L minus 1 having? All the numbers from 1 to L minus 1. What does prefix of R has? All the numbers from 1 to R. And what we need in prefix of L to R? We only need the numbers from L to R. So what should we subtract from prefix of R to only get the numbers from prefix of L to R? I think that this is the irrelevant section from 1 to L minus 1. So we would only subtract prefix of R minus prefix of L minus 1. So this would give me the sum of numbers from L to R. Okay. Now let's use this prefix array to solve this expression. Okay. So for n being even, all the numbers greater than n by 2 were coming as a positive number. So prefix of n minus prefix of n by 2. We need the sum of all the numbers which are greater than n by 2 as positive. Now the sum of all the numbers which are less than n by 2 as negative. So it would be prefix of n by 2 minus 1, and we can write a minus here. Okay. Let's ignore this plus. Now, and the number n by 2 itself as a plus minus. Okay. For n odd, n being even, it would be plus n by 2. For n being odd, it would be minus n by 2. Now let's discuss a bit more on the prefix array. Let's assume that we want the sum of numbers from L to R. Now let's assume that, okay, we are having this particular prefix. Now what would be the prefix array? It would be 1, it would be 0, 1, 3, 6, 10, 15 and 21. Now say we want the sum of numbers from 2 till 5. So 2 till 5, prefix of 5 minus prefix of 1. What is prefix of 5? 15. What is prefix of 1? 1. We will have 14. So we wanted the sum of numbers from 2 to 5. So what we wrote? Prefix of 5 minus prefix of 2 minus 1. And you can see that 2 plus 3 is 5, 5 plus 4 is 9, and 9 plus 5 is 14. So this expression is being satisfied. Now let's assume that we want the sum of numbers from 3 to 6. Okay. So if we want the sum of numbers from 3 to 6, what we can write? Prefix of 6, the sum of the first 6 numbers. And in the first 6 numbers, we don't want what numbers? We don't want the last two numbers. Okay, the first two numbers. So we will just write this. So this would be the sum of 3 to 6. Okay, now we got it. Now, how are we using this prefix array to solve our question? We want the sum of numbers from n by 2 plus 1 till n 2 times as positive. So we can write it as prefix of n minus prefix of n by 2 plus 1 minus 1, prefix of n by 2, and multiply it by 2. Okay, so we can get it in O of 1 time. And the second thing that we want is the sum of numbers from 0 till n by 2 minus 1. So how can we get it? We can get it by writing it as such: prefix of n by 2 minus 1 and minus prefix of 0 minus 1. So what is the prefix of minus 1? It is basically 0, and multiplying it by 2. Okay, and then taking the number n by 2 itself, being positive in the case of n being even and negative in the case of n being odd. So this is the approach to solve this problem. Now let's move on to my solution. Here is my code. This is the pre-compute function that computes the prefix of I. Prefix of I denotes the sum of the first I numbers. Now here t denotes the number of test cases. I call the pre-compute function. Here n is the number for which we have to compute the answer. If n is 1, we just simply print 2. Elsewise, we calculate the middle number, which is n by 2. Now, as I told you that it would be the numbers ranging from middle plus 1 till n would be taken 2 times positive numbers. So prefix of n minus prefix of mid multiplied by 2, and the numbers which are less than mid, which are from 0 to mid minus 1, will be taken 2 times as negative number, minus 2 times of prefix of mid minus 1. And the number mid itself would be taken as a negative number only once if n is odd, and would be taken as a positive number only once if n is even. After this, we would print the answer, and I would separately handle the test case for which n is equal to 1, and the answer for that test case would be equal to 2. Now let's submit the solution. You can see that the code got accepted. So if you have any doubt regarding this solution approach, you can ask in the comment section, and thank you for watching the video.